Hi everyone! In this video, we're going to learn how Docker volumes work and why persistent storage is important when working with containers. We'll understand what happens to container data when a container is removed and how Docker volumes help us preserve that data safely. We'll also explore concepts like bind mounts, persistent data, and storage management using hands-on examples. Let's get started. First, let's see what happens when a container stores data without using a Docker volume. We are going to create a simple container, generate a file inside it, and then remove the container completely. Here we are using the bash command to enter the container interactively. In this case, the container is based on the Ubuntu image. So this is similar to entering a small Ubuntu machine running inside the container. Now let's create a new folder called data. And inside that folder, we are going to create a file named test. The echo command prints a message, and with the greater than symbol, we redirect that output into the test file. So instead of displaying the text on the screen, the content gets saved inside the file. Now let's read the file using the cat command. The cat command allows us to display the content stored inside the file directly in the terminal. As we can see, the message was successfully saved inside test file. Now let's exit the container. At this point, the container is no longer running, but it still exists on the local machine. So now let's copy the container ID because we are going to remove the container completely. Remember that the file we created was stored only inside the container file system. So if the container disappears, the data stored inside it also disappears. This is one of the biggest limitations of containers when persistent storage is not configured. Now let's create our first Docker volume. Here we are using the Docker volume create command followed by the volume name. In this case, the volume name is my data. Docker will create a persistent storage area outside the container lifecycle. This means the data stored inside the volume can survive even if containers are removed. Now let's list the available Docker volumes using Docker volume ls. Here we can see the volume we just created successfully. Now let's use this volume inside a container. This time, instead of storing the data only inside the container file system, we are connecting the container to the Docker volume we just created. We do that using the -v flag. The -v flag is used to mount a Docker volume inside the container. On the left side, we specify the volume name, and on the right side, we specify the directory inside the container where the volume will be mounted. Notice that the file is now being stored inside the Docker volume mounted at /data. This means the data is no longer tied only to the container itself. Now let's create the file again, but this time using the Docker volume. Here we are using the echo command to generate a message. We redirect that output into the test.txt file located inside /data. Now let's verify the content using the cat command. As we can see, the message was successfully saved inside the file. Now let's exit the container. Next, we can use docker ps-a to see all containers, including stopped containers. And now, let's remove the container completely. At this point, the container no longer exists, but the Docker volume still exists independently. Now let's create a completely new container using the same Docker volume. And finally, let's read the file again using cat. Notice that the file still exists even after deleting the original container. This happens because the data was stored inside the Docker volume, not inside the container itself. Here inside Docker Desktop, we can also see the Docker volume we created. Notice that the volume exists independently from the containers. Even if containers are deleted, the volume can still preserve the stored data. This is what makes Docker volumes essential for applications that require persistent storage. Using Docker volume inspect, we can see detailed information about the volume, including where Docker stores the data internally on the host machine. And that's it for this tutorial. Today we learned why Docker volumes are important and how they help preserve data outside the container lifecycle. We also saw the difference between temporary container storage and persistent storage using volumes. These concepts are extremely important when working with databases, applications, and real containerized environments. In the next tutorial, we'll continue exploring Docker step by step. Thanks for watching and see you in the next video.